This is video FRQ2. So in this problem, they're giving you a graph with easy to determine areas on it. And so one of the first things I did is I found the area of each region. This one just a triangle, so 1/2 base times height. That a quarter of a circle. You're told it is right there. And so pi r squared times 4, and another triangle here. Note that these are negative areas since they're under the x-axis. And then a triangle and a rectangle. So found all the areas. We don't have to worry about that work later. Okay, but the problem doesn't really talk about that function. It talks about g. And g is the integral from 1 to x of that. Okay, and so realize x could be to the right or to the left of 1, so that's something we really have to note. Okay, so part A, find the average rate of change. That's simple, that's just a secant slope from x equals -5 to 5, but it's the average rate of change of g, not of f. Okay, and so I need 2 points. If I'm finding a secant slope, I need to find the y value of g when x is -5 and the y value of g when x is 5. And that's the first thing I did right here. Not on their work, they didn't show this work, but g of -5 is the integral from 1 to -5 of the function. Okay, the first thing I did is I flipped it and changed the sign, and then I looked at the areas from -5 to 1. And the areas are the triangle, the quarter circle, and the triangle. And so I just found their areas, added them up, and now I have g of -5. And so my ordered pair, one end of the secant slope in which I'm interested is -5 and 7 plus pi. I did the same with the g of 5, simpler because the areas are positive. We're to the right, so a very straightforward problem. Okay, I have another ordered pair, and now let's look at their solution. Okay, so notice that this is just your old slope formula. They call it the difference quotient. Okay, and we just find the slope and leave it on just in simplified form over here. Okay, part B. Find the instantaneous rate of change of g. So that's the derivative of g with respect to x at x equals 3. Okay, so we're finding the derivative of g, the derivative of that integral. It sounds like the fundamental theorem. You guys know that those are inverses. And so the first thing they write on their answer, okay, they don't give you points for it, but the derivative of g is simply f of x. And if they want the derivative of g at 3, that's just the y value of f when x equals 3. And so we look back at the problem, and we find the y value, it's 4. And notice that they want this written out again. The instantaneous rate of g at x equals 3 is 4. So always write your answers out fully. Show that you understand each part of the problem. Okay, part C. On what open intervals is the graph of g concave up? So now this is a second derivative problem. Okay, and we have to justify our answer. Well, the second derivative of g, the first derivative of g was f. So g double prime must be f prime. Okay, so the g double prime, the second derivative of g, is the slope of this curve. And we want to know when this is concave up, so we want to know when the second derivative is positive. So we're just going to find intervals on which the slope of f is positive. Okay, and we can see their answer right here where they give it to us. Notice that they wrote it as inequalities. I would assume they would take interval notation as well, but we're looking on the graph for where the slope is positive of f. And so from -5 to -2, and then again from 0, looks like to 3, and I think that's probably their answer right here. Notice that they're not including the endpoints. Okay, and then once again, write it out. Write out why you understand that this is true. So say what the answer is, and then tell them why. And I assume they would accept different explanations here. You have calculus teachers grading your tests. All right, part D. Find all x values from -5 to 5 at which g has a critical point. Okay, and so a critical point, remember, is where the slope is either 0 or undefined. Okay, and the slope of g are just the y values of f again. And so there are no undefined y values. So the only place we could have a critical point for g would be where f has a y value of 0. So there or there. So we've discovered our two locations for the critical points. Okay, and they would want to see this explanation that g has critical points where its slope is 0, and the slope is f. F is 0 at -2 and 1. Okay, and so notice that we have 2 of the 3 points already. Okay, the last point is coming from the classification. Would each of these be a min, max, or neither with justification? Okay, so a minimum would be where your slope is going negative, 0, and then positive. A maximum, your slope would be positive, 0, and then negative. So we look at this critical point. Remember, we're talking about the slope of g, the y values of f. And so here we have negative y values, a 0, and negative again. That would look something like this at that x value. Okay, negative slope, 0 slope, negative slope. So neither a min nor a max. But at this one, here we have negative y values, a 0, and then positive y values. And so negative y values, a 0, and then positive, this is going to be a local min. And let's look at how they worded their answers again. Okay, so g has neither local max nor min at x equals -2 because the sign of g prime doesn't change. And then, like we were talking about, g has a local min at x equals 1 because of the sign change from negative to positive. That's it.